Good morning, good afternoon, or good evening, depending upon where you live around the world. We've now moved on. I haven't completed fully the dome which utilises the pivoting hub, or the hub at which a bolt is put through the strut, so there is a pivoting component to it. But this is a rigid hub, the one I've been mentioning that I'm probably going to use, one that you'll often see in a lot of the drawings that you find on the net, and where it's just a single steel tube with tendons or long threaded rods going into the timber. At the moment, these ones are approximately 300 long. They may or may not need to be that long, but at the moment that's what I'm using just as a proxy for a threaded rod. You literally pre-drill the hole, undersize of course, and insert this threaded rod into your chuck, and you drill it into the timber. I've done this several times. It works very, very successfully. I don't really know the true strength of it, but because of the length and the embedment length, there's no way this is going to back out, and it's probably over engineered as far as penetration into the timber goes. However, I did make mention the other night that depending on the number of these rods, in this case it's a 12mm galvanized threaded rod, I may wind up using two, and in particular this hub here and here, and less likely actually in the bottom, but more likely all of these will have two tendons or two rods, because I feel, without having an engineer back me up on that, that this hub here is a high load stress area. This one, yes, definitely high load, but if we can restrict any hinging around this section, then the stresses on this will be, I'm going to say, manageable without being able to quantify that. I have actually thought about reinforcing this anyway with an insert, so that the two struts actually work in unison and create a better overall attachment for any other fixings that I may wish to consider adding. I also want to consider a method of restricting any splitting, because if there's any movement whatsoever, the timber is likely to split in this section here, and we don't want that. So if we can have a bolt or bracket arrangement to prevent that or restrict it, I think that can't be a bad thing to chase down. It may well be that we simply put a plate on the face of the timber and fix it through, because these screws won't be working in tension in the manner that I really find distasteful in end grain, screwing into end grain with screws, but they would be acting in shear, and that way they are working in the manner that is best suited. You're not going to have them pulling out because they're not actually under that load. They're trying to stop the timber from splitting. It may be that we need to put a small bracket, fabricate and put a small bracket around the ends, again fixing through the ends with screws, preventing this from splitting. These are all considerations. They're just tossed into the pile of questions that I've got. It may well be that through talking with engineers or fabricators, that they may be able to pass on a more elegant or a better way of doing it. So you can see at the moment we've got the hubs here. This is this one from here with the 6 tendons, or just threaded rod. Oop, that's not what I wanted to do. Undo, explode, and I'm just showing at the moment the hole positions. They will be specifically drawn to height. What they are, they's exactly to height, and I've coloured the inside of the tube because when I intersect the model, or this item with the with the other items models, I don't always get a fill in here because it's a curved surface, and it can be a bit. Sometimes it works. I've had it where it works, but this one I wasn't worrying about it, so I simply coloured the inside a darker colour so that when you're looking through, you get more of an understanding that yes, that's on the inside of the tube, but this is simply the between the two surfaces, the inner and outer surfaces. So. We don't want to go looking at something and misrepresent it and misunderstand what we're seeing. So, and of course, these will just be bolted. I'm contemplating, because these are actually on an angle to the hub. So this is prototype number 1. Prototype number 2 will be with these at 90 degrees to the surface of the hub, because the attachments, putting the nuts on here, they will be not hitting a flush or flat surface, and I can just imagine the problem that's going to cause. And that actually introduces I can't recall the name of the stress that's put on the bolt, but it's basically a rotational shear or tensional shear on the bolt, because you're loading up one very, very small surface. As the nut's trying to tighten up, it's trying to pull itself flush with the tube, and it actually puts shear pressure, but tensional shear, if there's such a term, on the bolt. So don't want that, because these bolts at this stage won't be high tensile. More likely to be mild steel, galvanized, of course, because the heat treatment in galvanizing can affect high tensile. This is outside my sphere of knowledge, but as I understand it, and I'd rather see, and these ones at the moment are 12 millimeter, I'd rather go up a grade of in a diameter to a 16 millimeter. Got no problem with the size, and put that in as a stronger tendon. But at this stage, this is, as I say, I can refer to it as prototype number 1, but I really do want to see the tendons more square, in parallel to the long axis of the strut, square to the end, to the tubes. Okay, so that's where we're at with this. Bit of a battle to get there. I had to put in surfaces such as this to make sure I get the planes for rotation correct. I can't recall what the heck I did before, so I did something, because I didn't have to do this. But sometimes you'll have to do, make a sidestep or revisit a method that you thought you already knew, the drawing method. So don't be too surprised that, well, if you've got better memory than me, which is more than likely, you'll be able to retain the information. But this is a step further along. As I say, I will still do a little bit of finessing and cajoling of the hubs and struts in the other model. I'll likely use exactly the same foot on this dome, of which either of tongue tied, it's getting late, of type 1 or type 2, the prototype for the hubs, regardless of which one. I think the square foot, the fabricated foot for the base, is going to be the best way forward, the easiest to build. There you go. big sigh by me again. I do a lot of that of late when I'm designing this, but quite happy with where we're at the moment. The next one will be looking at having square, still having the angled ends on the struts, but the tendons angled to suit the hub face. Okay, I'm waffling again. Better go, because once that starts happening, it's no good for anyone. Okay, see you later. Bye.